So let's proceed with testing how we can see the NAT translations. So first, let me ping if I can reach DNS server from the router. It will work, but yeah, let's see. Yeah, it is working. Uh, so question is verify that as you can see, I have already filled out the questions. Uh, Verify that outside PC can access internal servers using the DNS name. Let's take 102. I think Cisco.com is one of the site. Yes, it's working. You can see it did work. Uh, Facebook.com we will open on 103 because I need to show you some thing. Show IP NAT translation. So you can see there is some ICMP. ICMP, yes, we did try to ping the from the router to the DNS server. This is that entry. The protocol we used for ping is ICMP, and then we try to access a server. This is where the translations happen. So if I want to talk about exact, see 11102 PC tried to access 8.8.8.9. 8.8.9 is the Cisco um, map to DNS URL. How you can confirm that? NS lookup. Uh, this also gets generated some entries, but anyway, we can just try it out. Cisco.com. Yes, you can see Cisco.com is tagged to the IP address 8.8.9. So that's why it's so how you can understand with this output. Let me tell you, this section is protocol. What's happening, what protocol is using, like I said, ping, ICMP, telnet, or like when you're trying to access a server using HTTP, it uses TCP. We can see here. And what is this? Inside global, inside local, outside global. What is this? It is very confusing. So inside local is your local mission which is trying to ping. Previously when we try to ping, that is from the router. That's why we have 8.8.100, because that is the router outside facing interface from where we try to telnet. Let's see inside PC which we did access the website is 10.10.0.2. What is this 105 and 106, Jaya? We use the port 80, right, for telnetting. What is this port? So this is where overload command helps. Overload command and patting helps. So for example, 10, let me show you from 103 accessing facebook.com. Facebook.com. Yep. Let's go on to NAT translation. Yes. You can see there are 1.1.102 which tried to access 8.8.9. We have one more 103 which is inside PC tried to access 8.8.10. 8.8.10 is facebook.com. It's the DNS tagging, that IP tagging that has been done. So you can see inside global, that means what the global interface or the internet sees the inside traffic as 8.8.10 only, but port keep on changing. This is to identify which communication is happening. So 10.1.1.102 is tagged to, let's say, port 1025. So that communication keeps on happening with that port to identify which inside is trying to connect by differentiating, because the IP is different, same, which is basically the router facing IP. This will be the IP that global or the internet will see. It will not see the IP of 10.1.1.103. That's why when you're trying to access internet, no one can see. NATing will happen automatically in your mobile. Also, you browse internet, no one will see your private IP address. They will only see the public IP address. sometimes it gets changed, sometimes like this. When multiple, you can, by using overload and patting, you can just mask not only your IP but also port numbers. But the port numbers, for the router to identify, it keeps on setting some sequence numbers: 104, 105. Next communication will be 1029. Let me see, 1033 tried to ping cisco.com. It maybe becomes 102, 1029. Let's see. Yeah, 1028. 1028 entry is there, right? 1029. Yes, yes, we have the new entry. 110.11.103 tried to access 8.8.9. It's tried to access, right? 103 tried to access 8.8.9. Yes, it is tagged with some different entry 1028. So this is how we cannot see the same entry up, right? We cannot see. Okay, there is no 1028 port. Yeah, that is how. So let's also see how in simulation it works. uh let us also do fifth one. Verify that, okay, we did the fifth one. Yes, internal PCs can able to access the outside internet servers using the DNF name. It happened. Verify that outside PC can access internal servers using their DNS name. Let's see. My http.com. Yes, it's working. You can see it's working. I can go inside. Yes, I can access this. If we have allowed 443 port as well, we can able to access, but now it doesn't work. So yeah, let me remove it. Let's try to access the FTP server. In order to access FTP server, you go into command prompt and FTP myftp.com. Yep, username is Cisco, password is also Cisco. David set like this. I think I didn't given the correct password. Let me see. Cisco. Yep, yeah. Now I logged in correctly. You can see all the files that are in FTP server. Let's see. Let's see the netting translation. Uh, we got, yeah, 8.8.20. Let's see this entry. 8.8.20 tried to communicate via port 21, which is FTP, to 10.1.1.0.1, but the mask or the IP that outside network sees is 8.8.201. That's what will happen. Let's see in the simulation as well how it works. Okay, let's go to simulation. Let's see how this works. Let me quit it. Quit. Reset the simulation. Go to command prompt. Yeah, telnet. Instead of telnet, let me go back to browser on my. Ah, oh, okay. My http.com. Yeah, let's try to see how it works. So first, it needs to resolve its DNS entry. So you can see outbound traffic consists of DNS query. Let me show you actually. It uses port 53 for resolving the DNS query. So DNS query is myhttp.com. What this does next is, you can see in Packet Tracer as well. Uh, this is the starting, right? Yeah, this is the starting. The DNS client sends a DNS query to DNS server. So it will go to 8.8.8 server basically. let's see. So traffic went to switch and then to DNS server. So this result, DNS query will resolve the URL saying, boss, this is the IP. Let's see the outbound traffic. So 8.8.8, which is DNS server, replying back to 8.8.20 with its DNS result, query result. Let's see. Yeah. DNS query myhttp.com with the DNS results. Boss, 8.8.200 is the DNS IP of DNS URL myhttp.com. It got its results. So this packet is done, verification is done. Next, what it tried to did was the HTTP client make a connection to the server 8.8.200, but the server is 100. Let's see how it works. So it went to switch and then to router, because router is the it needs to reach to router. Let's see the inbound traffic. 8.8.20 means the outside PC wants to reach to 8.8.20, which is the results of DNS query. But when it's leaving the router, it got translated. Source is 8.8.20 same, but the destination becomes 10.1.1.1.10. You can see the here 10.1.1.1.10. It got translated to 10.100. Then it sends to the switch. Let's see how the packet look here. Uh, source is 8.8.20, destination is 10. I think here also it will be same. Let's see the return traffic. Servers that HTTP server sends some result. Let's see what it's saying. Source is sending to the destination 8.8.20. Let's see if source will be same, because if source will be same, then the natting has no use. It will change, but yeah. Source is same, destination is same, but when it comes to outbound, when it's leaving the router, natting again takes place. It didn't see that it's coming from 10.1.1.10, but it got masked to. As we configured natting, you can see HTTP with 200 is being mapped to 10.1.1.10. So we can clearly see the source of IP address changed to 8.8. So it's like it's coming from 8.8.200, but actual server HTTP server is 10.1.1.10. Okay, yeah. Uh, Very much we got the results. Yes, it went to PC. It will try to access. Let me go to real time. You can access the website. That's it. FTP also same situation. If we want, we can search. You go to the simulation. Understand how the packet transfer takes place. Um, this is the real use of Cisco Packet Tracer. It shows how the traffic is being passed from one place to another place. Let's say Facebook.com. And also one more beautiful thing about this packet tracer is it will clearly show from here the DNS client sends a DNS query to DNS server. The device encapsulates the PDU into a UDP segment. The source IP is not specified. The destination sets its to port IP address. The destination IP address is not same subnet. It is not broadcast address. The default gateway is set. The next hop is the unicast. Our process looks the auth table. The next process the frame. The device encapsulates PDU into Ethernet frames. Fast Ethernet 0 sends out the traffic frame. Let's see. So it is going for DNS query, and the DNS results will come. Yeah, your DNS answer is 8.8.10. You try to know about Facebook.com. It sends that traffic to 103, then 103 try to access the server, it will send a communication, the incorrect ones as a switch, it broadcasts the traffic, the incorrect one gets discarded while the correct one proceeds to result proceeds with the result. So that's how. Okay, let's go to real time. Facebook.com, you can see, yeah, you can access Facebook.com. Okay, so this is how netting takes place, and this is how you need to understand. Now we got multiple entries here. Yes, you can see multiple entries. But how do you identify that? 10. See, each communication is happening when we try to DNS query. The port got translated to some other port so that the inside global or the global internet cannot see. So that's how. Sometimes we try to connect facebook.com, we try to connect cisco.com. These are the uh, entries. You need to understand how what it's saying, what this IP NAT relations is saying. So this is how you try to achieve the natting. um, that's all for this video. Thanks for watching.